Hello, everyone. Come to us and ask all the questions that people need to know. For billions of years, a conflict beyond our senses has shaped life on Earth. It is a war more ancient than any civilization, relentless and all-consuming, but it doesn't rage on battlefields or in the skies. It unfolds in every inch of our world, deep within every drop of water, soil underfoot, and even across your own skin. The participants are too small to see, and yet, their epic struggle claims trillions of lives each day without our notice. This is the invisible arena of bacteriophages, the deadliest entities on our planet. Bacteriophages, or phages for short, are not quite alive in the way we understand life, nor are they truly dead. Instead, they occupy a strange place in the biological world, existing somewhere in the gray area between life and non-life. Viewed under a powerful microscope, phages appear as if crafted by some imaginative mind rather than evolved by nature. Their heads are shaped like icosahedrons, geometric wonders with 20 triangular faces and 30 sharp edges, giving them an almost sci-fi aesthetic. Attached to this head is a tail, often ending with delicate leg-like fibers that allow them to latch onto their targets. To appreciate their scale, consider this. Phages are the most abundant biological entities on Earth. They outnumber every other organism combined, including the very bacteria they hunt. Wherever you find bacteria, you find phages in staggering numbers. Billions reside on your skin, on your eyelids, within your intestines. Each of us is an unwitting stage for their ancient war. This might make you uneasy, especially when you learn that phages are responsible for more deaths than any force on Earth. Every single day, they annihilate countless bacteria. But unlike many viruses, their targets are not human or animal cells, but bacteria themselves. The specifics of their predation are worth marveling at. Phages are extraordinarily specialized, often tailored to hunt just one species, or sometimes even a single strain of bacteria and a few close relatives. Picture a vast arsenal of highly targeted cruise missiles, each engineered to seek and destroy only a specific enemy combatant, leaving everything else unharmed. When a phage encounters its chosen bacterial foe, it latches on tightly with its tail fibers, identifying unique receptors on the bacterium's surface. With remarkable efficiency, the phage deploys a sort of molecular syringe, injecting its genetic material into the bacterial cell. The hijacked cell is forced to become a virus factory, devoting its every resource to assembling fresh phage components. Heads, tails, and fibers. Only when the bacterium is packed to the brim does the final horror unfold. The phage commands its captive to produce an enzyme called endolysin, which ruptures the bacterium from within. The explosive pressure forces the cell's contents, and a new legion of phages, out into the surrounding environment, ready to begin the cycle anew. This cycle plays out on an incomprehensible scale. In the world's oceans alone, estimates suggest that phages destroy up to 40% of all bacteria every single day. Imagine the ocean's role in turning over the web of life, facilitated in large part by phages. Yet these microscopic predators, for all their deadliness, have one critical limitation. Like all viruses, they cannot exist independently. They require a host to propagate. Outside their specific bacterial victims, phages are little more than packets of genetic information, utterly harmless to other forms of life, including us. Ironically, after billions of years spent locked in warfare with bacteria, phages are now garnering the interest of the second deadliest entity to ever walk the planet, humans. Today, we are investigating ways to deliberately harness phages for one of our most critical battles, the fight against bacterial infections. To understand why, it's worth reflecting on our own troubled history with bacteria. Not so long ago, something as minor as a scraped knee or drinking from an unclean stream could spell death. Bacteria, in those days, were merciless adversaries, responsible for plagues and the silent decay of countless lives. This changed dramatically about a century ago with the discovery of antibiotics, miraculous drugs derived from fungi that could poison bacteria with surgical precision. Their effectiveness was so profound that humanity's collective fear of bacteria began to fade. We started using antibiotics liberally, even carelessly, for ailments both minor and imagined, stripping away our respect for their power. But nature, as always, adapts. Bacteria responded to our relentless attack by evolving defenses. Through chance mutations and gene sharing, they developed resistance to our drugs, transforming once defeated enemies into superbugs capable of surviving our most powerful treatments. This crisis is escalating. By 2050, experts warn that superbugs could kill more people annually than cancer. In the United States alone, resistant bacteria already claim over 23,000 lives each year. Hence the renewed interest in the ancient warriors, phages. Unlike the indiscriminate devastation wrought by antibiotics, phages are precision weapons. Each targets only its intended bacterial prey, leaving the beneficial bacteria of our bodies untouched. This specificity is precisely what makes phages so promising and so safe for use in humans. Our cells differ so greatly from those of bacteria that phages can do us no harm. Every day we coexist with billions of these viruses, and our bodies simply disregard their presence. You might wonder, if we use phages to destroy bacteria, wouldn't bacteria evolve to resist them too? The answer lies in the evolutionary arms race waged for billions of years. Bacteria have indeed developed many defenses, but phages evolve just as rapidly, constantly devising new strategies to overcome bacterial resistance. Incredibly, even as bacteria escape one menace, they often lose their resistance to others. For example, when bacteria become immune to certain phages, they may become susceptible to antibiotics once again, trapping them in a lose-lose scenario. Recent medical cases offer hope. In one instance, a man suffering from an untreatable superbug infection in his chest cavity was given a mixture of phages, each tailored to his infection, alongside antibiotics that had previously failed. The result was astonishing. Within weeks, the infection cleared. Though still experimental and facing hurdles in widespread adoption, such victories suggest a path forward. Phages are now the focus of major clinical trials and increased research funding, signaling a shift that could reinvigorate our fight against bacterial diseases. As antibiotics lose their potency, we may enter an era where the world's deadliest killers become our staunchest allies. Embracing the profound power of phages and deploying them wisely could turn the tide in the age-old war against bacteria, a war that, for now, continues unseen all around us.